You know, in modern software, it feels like we're always caught in this tug of war. On one side, you've got this incredible demand for performance, for handling thousands of things at once. But on the other side, there's this desperate need for code that's actually simple, readable, and, maintainable. So, how on earth do you get both?
I mean, that's the million-dollar question for every developer, isn't it? You're building these big, complex systems, cloud services, microservices, whatever. You need them to be blazing fast, but you absolutely cannot afford to build a tangled mess of code that's going to come back to haunt you. So, is there really a way to have it all?
Well, let's jump back to 2009. At Google, engineers were dealing with this exact problem, just at a mind-boggling scale. They realized they needed a new tool for the job. And the result? It was Go, a programming language built from the ground up to be pragmatic, super efficient, and just perfectly designed for the way we build software today.
To really get what makes Go tick, you have to understand its core philosophy. See, it's not just a random collection of features. It's a very specific, very opinionated way of thinking about building software. And it all really boils down to two main ideas.
And here they are. On one hand, you have radical simplicity, this relentless drive for clean, readable code without any extra fluff. And on the other, you have first-class concurrency, which basically means the ability to do many things at once is baked into the language's DNA. It's not an afterthought. And pretty much every single design choice in Go serves one of these two masters.
Now this slide right here perfectly captures Go's revolutionary idea about concurrency. The old way, on the left, is kind of like a chaotic free-for-all. You have different tasks all trying to grab and change the same piece of data, and you need all these complicated locks to keep them from crashing into each other. It's a recipe for disaster and bugs that are a nightmare to find. Go just flips that whole idea on its head.
This brings us to what is basically the central mantra of Go. Instead of having all your tasks fight over the same piece of data, you just have them talk to each other. You give them a dedicated line to pass messages back and forth. They coordinate their work without ever stepping on each other's toes. And this one simple shift makes everything safer and so much easier to understand.
Okay, so that's the philosophy. But what does it actually look like in practice? Let's dive into how this big idea is built directly into Go's two most famous features, Go routines and channels.
First up, the Go routine. Think of it as an incredibly cheap, lightweight little worker. Now, unlike traditional operating system threads, which can be kind of heavy and slow to create, Go routines are managed by the Go program itself. This means they are ridiculously fast to spin up and tear down. You can literally run thousands or even millions of them at the same time.
And when I say lightweight, I really mean it. A brand new Go routine starts with a stack size of just 2 kilobytes. That is tiny. This insane efficiency is exactly why a single Go app can handle a massive number of concurrent tasks without even breaking a sweat. It's pretty much perfect for servers that are getting hammered with user requests. So how do all these thousands of Go routines talk to each other without creating total chaos? Well, they use channels. And the walkie-talkie analogy is just perfect. You launch a Go routine to do some work, you give it a channel, a walkie-talkie to report back on, and when it's done, it just sends a signal. The main program is just listening on that channel and it safely gets the result. What does this mean? No complex locks, no dreaded data races, just clean, predictable communication.
Okay, so that's concurrency. Let's switch gears and look at the other pillar of Go's philosophy, that obsessive focus on simplicity and readability. This is what the pros call idiomatic Go.
Go has a really strong opinion here. It basically says that all those arguments developers have about code style, tabs versus spaces, where to put the curly braces, are a complete and utter waste of time. So it gives you a tool that makes those arguments totally impossible. That tool is called Go FMT. You can write the messiest, most unaligned code you can imagine. Run one simple command, and poof, it's instantly transformed into the official standard Go format. This just ends the style debates, period. All Go code, no matter who wrote it, looks and feels the same, which makes it incredibly easy for anyone to read and maintain.
And that simplicity is everywhere. Go only has one kind of loop, the for loop. Your if statements don't need parentheses. Error handling is super explicit. A function will return both a value and an error, forcing you to think about what could go wrong. The language is kept intentionally small and simple, so you spend more of your brain power solving actual problems, not fighting with the syntax.
So we've seen the how. Let's talk about the why. How do all these design choices actually translate into real-world performance?
especially when you put it up against other popular tools like Node.js.
Okay, this is where the rubber meets the road. Look, Node.js is fantastic for handling a ton of network requests, but its single-threaded nature means it can really get bogged down if you give it a heavy-duty calculation to do. Go, on the other hand, was literally built for a world with multi-core processors. Those Go routines let it spread work across all available CPU cores without even trying. The result? A system that's amazing at both networking and CPU-heavy tasks, all while using less memory and scaling more effectively.
This unique mix of raw performance and easy concurrency makes Go an absolutely perfect fit for a certain kind of problem. It has become the go-to choice for things like high-traffic servers, cloud infrastructure, distributed systems, basically any high-performance system where efficiency and reliability are everything. When it comes right down to it, Go's real value is that it's a language built for the hardware and the infrastructure we use today. It was designed from day one to take full advantage of multi-core CPUs and to build the huge, scalable, resilient systems that power the cloud. It is, quite simply, a modern solution for modern problems.
So this all leaves us with one final question. Go is opinionated. There's no doubt about it. It trades a little bit of flexibility for a whole lot of simplicity, speed, and safety. It kind of forces you to work in a certain way. And the question for you to think about is whether that trade-off, that powerful combo of performance and radical simplicity, is the right philosophy for whatever you're building next.